While revealing a major design change to SpaceX's interplanetary spaceship, Elon Musk revealed that the Starship will soon be made of different materials. Hey guys, welcome back to our channel Elon Musk World, where we tell you all the latest news about Elon Musk and his multi-billion-dollar companies. In today's video, we are going to tell you about a major design reveal. Elon is always up to something, and this time it's all about stainless steel. SpaceX is about to make a major change in its Mars-colonising Starship spacecraft. The Starship prototypes were made of stainless steel alloy known as 301 by the California-based company. However, aerospace engineers have been using that particular metallic blend since the mid-19th century, and Elon Musk believes it's time for SpaceX to change. During a keynote speech at the Satellite 2020 conference in Washington, D.C., Musk said, "We should be able to do better in the 2020s than they did in like the 50s, you know? So I think we'll start switching away from 301 maybe in the next month or two." The 100-passenger Starship and Super Heavy, the massive rocket that will launch the ship off of Earth, will both be made of stainless steel, according to SpaceX. Musk stated that the company will simply switch to a different alloy, whose constituents SpaceX will tweak over time. Stainless steel is much less expensive than the carbon fiber material that SpaceX had planned to use for Starship and Super Heavy, and it has other significant advantages, according to Musk. Stainless steel, for example, handles heat far better than carbon composites, he claims. And that's critical for the reusable Starship and Super Heavy, which will both be making numerous high-energy trips up and down through Earth's atmosphere. Musk explained why he made the switch in a recent interview with Popular Mechanics. One factor was cost. Carbon fiber costs $135 per kilogram, and 35% of it has to be discarded. You cut the fabric, and some of it you can't use, said SpaceX founder and CEO Elon Musk. As a result, the true cost of the material is nearly $200 per kilogram, whereas stainless steel is only $3. Musk told Popular Mechanics editor-in-chief Ryan D'Agostino that stainless steel's high melting point is also a big plus. So for a steady-state operating temperature, typically aluminum or carbon fiber, you're limited to around 300 degrees Fahrenheit. It isn't all that high, Musk stated. You can go a little higher than that, perhaps 350 degrees Fahrenheit. You'll really be pushing it to 400 degrees Fahrenheit. It deteriorates. There are some carbon fibers that can withstand temperatures of up to 400 degrees Fahrenheit, but there are strength drawbacks. Steel, on the other hand, can withstand temperatures of 1,500 degrees or 1,600 degrees Fahrenheit. Musk also talked about SpaceX's plans for the Starship's novel heat shield system, which will use transpiration cooling. You only need two stainless steel layers, which are connected with stringers. You can flow either fuel or water between the sandwich layers, and then you have micro perforations on the outside, very small perforations, through which you can bleed water or fuel. D'Agostino was informed by Musk. This has never been proposed before, to the best of my knowledge. A metal's behavior is somewhat characterized by a crystalline structure at temperatures below ambient. Temperature has a big impact on the yield and tensile strengths of metals like iron, molybdenum, vanadium, and chromium that catalyze in the body-centered cubic. In a narrow temperature range below room temperature, these metals lose their ductility. The tensile strength of metals with face-centered cubic structures, such as aluminum, copper, nickel, and authentic stainless steels, is more temperature-dependent than their yield strength, and the metal's ductility often increases as the temperature drops. Transformations in compositions that are normally stable at room temperature, but metastable in cryogenic temperatures, can have a significant impact on their behavior. For example, a normally ductile and tough stainless steel such as 301, 302, 304, or 321 can particularly transform to a BCC structure when subjected to gross plastic deformation and cryogenic temperatures, resulting in a loss of ductility and toughness. At cryogenic temperatures, a fully stable stainless steel 310 cannot be transformed. The 300 series steels provide a good balance of toughness and weldability for low-temperature service. Their strength properties in the annealed state are adequate for ground-based equipment but insufficient for lightweight structures. Fabricators can take advantage of the alloy's strain-hardening properties and use it in a highly cold work conditions for aerospace applications. Low weld joint efficiencies caused by annulating during welding and the transformation to martensite that occurs during cryogenic exposure are the two main drawbacks of cold work materials. The transformation problem is solved by selecting fully stable grade type 310. When cold worked before aging, precipitation hardening A286 stainless has even more strength. 9% nickel steel is the only alloy steel recommended for cryogenic service. Because of its low cost and ease of fabrication, it is suitable for service down to -195°C and is used for cryogenic transport and storage. Other alloy steels are suitable for low-temperature applications. Steels A201 and T1 can withstand temperatures as low as -45°C. Nickel steels with 2.25% Ni can withstand temperatures as low as -59°C, and nickel steels with 3.5% Ni can withstand temperatures as low as -101°C. Starship's entire purpose is to be an interplanetary vehicle, which means it will be exposed to both freezing and scorching temperatures as it ascends and descends into planetary atmospheres twice. As it turns out, stainless steel shines in this situation, as it has a high tolerance for temperature variations that few other materials can match. When a Starship enters Mars's incredibly thin atmosphere, the amount of drag on the vehicle is increased in order to slow it down as it falls. Dragging generates heat, which even stainless steel can't handle in this case. SpaceX plans to use a liquid methane pump beneath the Starship's surface to cool the ship's descent, which will essentially fight back against the heat in the same way that humans sweat in hot weather. The Starship prototypes aren't particularly impressive right now, but SpaceX plans to improve the manufacturing process as it works toward building one of the most ambitious interplanetary space vehicles of all time. It'll be interesting to see how this develops. Indeed, SpaceX's long-term vision hinges on rapid and frequent reusability. Musk has stated that the only way to reduce the cost of spaceflight to the point where Mars colonization and other ambitious exploration feats become economically feasible is to fly the same hardware over and over again. He also stated that the Starship is being designed to be relaunched an hour after landing, with zero nominal work. Propellant is the only thing you would expect to change on a regular basis. Musk added that SpaceX wants to be able to launch each Starship 3 times per day. If it weren't for the need to line up the ships properly for landing near the launch site, a process that would take 3 to 4 orbits each time, the target number would be higher. The mechanics are simpler for Super Heavy, as it will return to Earth for a vertical landing shortly after liftoff, as SpaceX's Falcon 9 and Falcon Heavy rockets already do. Starship, on the other hand, is designed to travel much further afield and will not be defined by its ability to turn around quickly. Musk has stated that every 26 months, 1,000 or so Starships will depart from Mars, when the Red Planet and Earth align favorably for interplanetary missions. If all goes according to plan, these mass departures will assist humanity in establishing a sustainable city on Mars within the next 50 to 100 years. A Starship won't need Super Heavy to launch itself off the Moon or Mars, as their gravitational pulls are much weaker than Earth's. And this is it for today, guys. What are your thoughts? Tell us in the comments section below, and don't forget to like and subscribe. And thank you for watching.